Hey guys, this is Michael from Team 4411S, and today this will be our third episode of our little tutorial for coding in Prose. Okay, so in our last tutorial, just quick recap, we went over driver control and made some dedicated functions to help you process all of the controller input so that you don't have to hard code everything yourself. So just an example, go to our drive source file. So we have this function called setDriveMotors that takes our controller input, processes it with that dead zone we talked about, and then sets the drive to that value. And we have very similar functions, including our helper function called setDrive for all of our other different mechanisms. Okay, so today we're going to be doing some very basic autonomous code, just a function that lets you drive forwards and backwards so that you can use it in your autonomous. Next, we will be covering turning, but that will be for a later episode. Okay, so we're done with driver control code for now, so let's open autonomous, which is what we're going to be doing today. So in this autonomous source file, this is the function you're going to want to edit, because this function, autonomous, right here, is what the robot runs when it goes into autonomous. So the first thing you probably want to do is separate it into different functions. Now I know that this has been a common trend in a bunch of our other episodes, I guess, but it's a very useful trend, obviously, because it lets you organize your stuff. So instead of just like hard coding all of your autonomous stuff in here, let's say you want to choose between 4 different ones. So like, I don't know, let's call it, did I space it out? Void, red, I don't know, red left corner, for example. So if you're in the left corner on the red side, and then you want another one to run if you're on the blue left corner. And then you want another one for your red right corner for whatever reason. So you can have different autonomous routines for every single position that you're in. So you want to create different functions for all of these. So right now we're just going to have red left corner for now. And we want autonomous to run red left corner. And using this organization method, you can make it really easy to change your autonomous. So for example, if we have all of these commented here, so let's do red right corner, blue left corner, and blue right corner. So whichever one you want to use, you just uncomment, and then boom, it's ready to use. Now obviously there's not a red right corner defined, so it's going to error out, but once you make those functions, then you can use them pretty easily. So for example, if we uncomment red left corner, it'll run whatever is in here. Okay, so now that we've got that figured out, most people, what they would do in their autonomous is they'd say like, while the encoders are less than a certain number, then drive forward. But like that's hard coding, and it makes programming a lot harder than it has to be. So like, for example, what you want your code to look like is like, let's say you have a function called drive forward. So you want to say drive forward, I don't know, maybe 100, 500 units, turn left 500 units, intake, like stuff like that. So it makes your code a lot more readable, and it eliminates a lot of that hard coding stuff. So the way you do that is by making those little functions that look like drive forward and turn left and all that stuff. So today we're just going to be doing the drive forward function, and the drive backward function, of course. But there is one thing I want to take care of beforehand, and that is in the Initialize file. So don't worry about all of this code. All you want to worry about is this function Initialize. This is what runs when your robot connects to the controller. This function is just something that Prose made, because if you see this little line here, LCD Initialize, if you guys remember the Cortex system, these LCD screens, the Prose has actually coded a virtual LCD in the sense that your V5 brain acts exactly... Oh, I just opened Photoshop, my bad. Let's close out of that as soon as that opens. Sorry about that. Okay, so basically Prose made it so that there's an LCD screen with, I believe it's like 3 or 4 different lines instead of just these 2. But it's displayed on your V5 brain, and you can use it's a very helpful tool for debugging if you want to just print stuff onto there. So I'm going to leave these 2 lines here, and I want to make it the first line say 4411S was here. Okay, Now you can change this obviously to whatever you want, but if you do want to, for whatever reason, print to the LCD screen, I'll just give you a quick rundown right now, even though we'll cover this later. It's this function right here, set text, and then this number is the line. So the first line is actually 0, but you can do 1, 2, 3, etc. For the different line numbers, and then you just set the text right here. Okay, so for the rest of our initialize function, which again is what runs when you connect to the controller, I want to worry about some stuff with the motors right now. So if you remember, motors can have, for V5, the motors can have 3 different brake types. I believe it's brake, hold, and wait, I think the one that doesn't do anything. I forgot what it's called. Here, let me see. So let's set our drive motors to a certain type. So drive left back dot set brake mode, I believe it is. So let's look at what the different types are. So there's mode. Okay, so it's brake, coast, and hold. So we're gonna do coast for a specific reason. So I'll explain what the 3 different types do very briefly. So coast, whenever this is what happens when you set the motor to 0. So if it coasts, it just lets the motor do whatever it's doing. If it wants to keep moving for whatever reason, like if it's on a flywheel and you still have that momentum from it moving, it'll keep coasting. If you type in hold, then it'll try and keep that motor at that position. So if your arm is moving and then you suddenly set it to 0, it's going to apply motor power to that motor to keep it at that position. And then if you try and move it down forcibly, it'll move back to that position. And then if you do brake type brake, which is kind of interesting naming pros, it'll do the same thing as hold. It'll try and keep it in that position, but if you forcibly move it, it won't move back. So it'll resist your motion, but it won't counteract your motion. So you might think that hold would be the most useful since it keeps you in the position that you're at, but we like to do things manually our way, so we're going to do coast for all of our drive motors. So let's do this for all of our drive motors. If you think about it, well, we'll take care of the rest of the motors in just a second. So let's do our drive motors. Okay, so all of our motors are set to coast because we're going to have our own manual brake in our functions. Let's think about the rest of our motors. So our lift, set brake mode. Okay. So what do we want to do here? So let's think about it. In driver control, you're moving your lift up to a certain spot for whatever reason to score on the towers. You probably don't want it to move back down, so we're probably going to want to do hold on this. For your intake, I have not played this game on a robot because I'm not competing technically. So I would assume that you'd probably want it to be on hold, but you could probably also put it on brake or coast. But I'm going to put it on hold just in case. You guys can change this to whatever you need. This is going to be intake left, and then you want to do the same thing for intake right. And then the last one is our angler, which I'm going to put here. Set brake mode. Your angler you probably also want to have on hold because it's very important that your stack or your tray doesn't move like very easily. So you probably want to hold your position there. Later on in the series, once we get to like custom PIDs, we're probably going to change all of these to coast. But that's much later on. This is just, basic stuff, of course. Okay, so the reason you want to do this in Initialize is because you want to have these motors set to year from the very beginning. Okay, so now what we want to do is we're going to create our function for our drive stuff. Okay, so let's open up our drive files. Okay, remember how we had our section for driver control functions? Now we're going to have our section for autonomous functions. And the very first one that we're going to be creating today is we're going to call it, all right, I'm just going to start with the more advanced stuff right now. So we're going to call it translate. Now, the reason that I call this translate is because think of the field as a coordinate plane system. If you remember from algebra, geometry, whatever class it was, the word translate in mathematics refers to moving a set of points a certain distance away from where it was. So if you think of the robot as a point on the field, you're translating it a certain distance away. And this function, we want it to, you could have a function, for example, called like drive forward, and then you want one called drive backward, but we're going to make it a little easier, and we're going to have this one translate function take care of both driving forwards and backwards. So this function is going to need two parameters, units and voltage. So if I haven't mentioned this before, I'm not sure if I did in our last episode or maybe the first one. One of the really nice things about pros is that you can set your motors to a certain voltage instead of a certain velocity, which is really nice because V5's velocity control is not the greatest. So we want to be able to control the actual raw voltage. And one of the nice things about this is that it doesn't limit your velocity. So for example, your 200 RPM motors on your drive base, if you're using velocity control, the V5 is automatically going to limit them to 200, so they can't go any higher. But if you're using voltage control and you just set it to max voltage, it could actually go higher. An interesting case of this is at Worlds, people were asking me if my robot was sped up, even though it was direct 200 RPM on the base. But since I was using voltage control, it was likely going around 220, maybe 230, if it wasn't under any significant load. Okay, so now that we've created this function header in our header file, we're going to go to our source file, and we're going to actually write out this function. Okay, so this is where having our little helper function called setDrive comes in handy. So we're going to separate this function into a few little sections. So one section, we're going to reset the motor encoders. I'll explain what this means in just a second. Then our second step is going to be, let's see, drive forward until units are reached, and then we want our brief break, and then we want to set drive back to neutral. Okay, so these are our 4 different things that we want to be able to do. Now, the first thing, resetting motor encoders. If you're in a more advanced programming level, then you probably don't want to reset them. You probably just want to take the current units and then add these units to it so that that's your new target value. But if you don't understand what that means, we're just going to reset the encoder units back to 0. So that now that they're at 0, we can just move the drive until this number of units are reached. I'll try and explain this more in depth as we make the function. So what we could do is just say drive left back. Okay, so the way that you reset the encoder units back to 0 is if you use something called tear position, which is the function that pros uses to do that. So you could manually say, drive left back out tear position, drive left front tear position, but you're going to want to do this in several different functions that we're going to make. So we're going to make another helper function. It's going to be called reset drive encoders. It's not going to take any parameters, and we're going to do this text in here so that we don't have to type this out every single time that we want to do this. You're going to notice this is going to be a very common trend in our program because you want to be doing this a lot so you can, I keep not typing that capital B, so that you can do this as often as possible and save as much typing as possible. Okay, I cannot type today. So instead of doing this, we're just going to say reset drive encoders. And we probably want to define this helper function. Now, I mean, you don't need to define the helper function here because you're only going to be using it in your drive file, but it's good to have them all defined anyway. Okay. So now that we have this first step done, we want to drive forward until the units are reached. So a really simple way of doing this is saying, so while the position of the motor, so let's think of it, let's just use the drive left one, or sorry, our left front motor for now. Drive left front, the way that you get the value of the encoder is .get position. So while this is less than our units, meaning, so let's say it starts at 0, so it's going to be less than units, and as you keep driving forward, your units will increase. So as this gets closer and closer to units, you want to set the drive to this voltage. So for example, if you want to set it to, remember, your full speed value is 127 for your voltage, then, and let's say your units are 500, so while your motor encoders are less than 500, set your drive to 127, which, quick recap, remember that this is the left side and this is the right side, but since you're driving straight forward, you want to set this to the same value. Okay. There's also one other thing you want to do, and that is to delay that 10 millisecond delay. Remember that from our driver control file, the motors only update their values every 10 milliseconds. So you want to put this here so that pros can run other tasks at the same time while you're delaying this one. Okay. So then our brief break. This one's really easy. You just set your motors to a very brief, a very small negative value very briefly. So for example, set drive a negative 10 for maybe 50 milliseconds. So by setting, so when you're done driving, basically, remember you're going full speed here if you set it to full speed. So you're gonna have some momentum when you're done, and your motors are on brake type coast, which is a good thing, I swear. So you want to get rid of that momentum by setting your drive to a negative value to stop yourself pretty quickly. This number can vary depending on the weight and size of your robot. I believe for our robots, which are relatively light, it was 50, but you might have to change this to 100 or 75, whatever floats your boat. And then you have to set your drive back to 0. And the reason you have to set your drive back to 0 is because if you don't, then once it's done delaying, your drive is still going to be at negative 10. So you need to set it back. Okay. So there's a few things we can change about this that we actually need to change in order to be able to go backwards. Because right now this can only go forwards. And what I mean by this is, well, let's say that your first action is to translate, let's say you want to go backwards. We want to go negative 500 units at a speed of 100. The way I prefer to do this is just, if you want to go backwards, then you just set the units to negative to signify a negative distance. But the speed itself is, if you understand physics, speed only has speed is positive because it doesn't have a direction. So it's always going to be a positive number, whereas the distance can be negative because you can move in a positive way along an axis, or you can move in a negative way. But skipping all that mumbo jumbo, if you want to go backwards, let's set the units to negative, not the speed. So right now, what this is saying is I want to drive backward at 500 units at a speed of 100. So remember that your units are negative 500 and your voltage is 100, right? Yes, okay. So remember that you reset your encoder units back to 0. But since this is negative 500, it's saying while 0 is less than negative 500, which is false because it's greater than, so it's going to skip this loop entirely. So what you want to do to fix this is check the absolute value. So you want to check while the absolute value of these encoder units, and you want to check the absolute value of the actual units that you're traveling. One thing you do want to change is you want to change this to fabs, which might seem kind of weird. What's my error here? Oh, that's my bad. Didn't do that. Okay. Always forget to put the end parentheses. One thing you do want to do here is use fabs because this function, getPosition, returns a double, which is an integer with a decimal place. And absolute value only covers integers, but if you use the fabs function, it covers doubles. Okay. So now, even if this is negative 500, it'll look at positive. It'll just look at the value instead of the sign. So while your encoders are, the positive value of the encoders are less than the positive value of your units. So even if this is going negative, so like from 0 to negative 100, it'll just assume it's going positive, and that just makes things easier. One other thing that we can change in order to make this work is that if you want to go backwards, well, you do want to set your drive to a negative voltage. So one thing that you can do is you can define a direction, for example. So we're going to make an integer called direction, and we're going to set it to the absolute value of units divided by units. And the reason this works is because this will be either 1 or minus 1, because you're dividing units by itself, but since you're taking the absolute value, let's examine the case of where it's negative 500. This will end up being 500 divided by negative 500, which would be negative 1. And the reason you want to do this is so that when you're going forwards, this value is 1, and when you're going backwards, this value is negative 1. So you can straight up just multiply your voltage by this direction. So in that case where our units were negative 500, now you're setting your drive to whatever voltage times negative 1. So it will be 100 times negative 1, so you set your drive to a negative number. Now don't forget to also set your brake to this direction, because if you're going backwards, you want to brake with a value of positive 10. Okay, so now it works for going forwards and backwards. The next thing you want to do in order to optimize this is to not just use your front left encoder. The reason that this is the case is because let's say you hit something on the way and you hit it on your left side. So now your left side is going slightly slower than your right side. You won't know that if you're just checking your left front encoder because you don't have anything to compare it to. So let's just keep this really basic. We're going to make another helper function to fix this called average drive encoder value. I know this is a super long name, but bear with me. It's just to be readable. Average drive encoder value. Okay. So what this is going to do is it's going to, instead of just checking the 1, it's going to average all of them. And I forgot we need to return a double because we're going to be returning something. Let's change it in here. Don't forget to save. Okay. So all you really need to do here is, well, let's make a double that averages everything. Or actually, we're just going to return it because it's more efficient. So what you want to do is you want to take all of your drive encoders, add them together, and divide by 4 to get the average. Pretty simple math. So we're going to take this because it is nice and ready for us. So we're going to add all of these together with all of our other motors. And I'm going to do it on a separate line just to make it easier to read. One sec. Okay, so we're going to do the absolute value of our left back motor. Oh, well, that was interesting. Let's do right back, or right front, and then we do right back. Okay. So now that we have all of them added together, let's put a parentheses and then divide by 4. So that will return the positive average of all of your encoders because you're using absolute value. So now that you have that, you can just replace this with while the average drive encoder value is less than this. You don't need to check the absolute value of this because it already returns a positive value for sure. Okay, so now we have a pretty, actually let's comment this. Define a direction based on units provided. Okay, so now that we have a pretty basic function, we're going to do one more thing to optimize it. So remember when I mentioned earlier what happens if your drive hits something and one side starts going slower than the other? You can actually account for this. There's a few ways to do it. The way that I would like to do it is with the gyroscope. So most people don't really use a gyroscope. It's a very underutilized sensor, but I want to use it for our turning functions and also to make sure that our drive goes perfectly straight. It might not just be because you hit something. It might be because maybe your left side has slightly more friction for whatever reason. Maybe your weight distribution is a little off. I don't know why. But maybe it just naturally goes a tiny bit slower. So you don't want your robot to curve. You want it to keep going straight to make your autonomous routines as accurate as possible. So let's get a gyroscope in here. So I believe it's pros ADI gyro. We're going to call it gyro. You can call it whatever you want. And then the port. So I think let's just do, I think for our angle we had a potentiometer. So we already used A here. So we're going to use B. And then what you can also do here is define a sensor scale. So you don't have to put this here. You can just do that. But for example, if you guys remember sensor scale back in Robot C, it just basically scales the value of your gyroscope because maybe it doesn't come with the right number out of the box. So for example, let's say that you turn your robot 90 degrees and the gyroscope only goes to 800 instead of 900 because it returns your angle times 10. So it should be returning 100 more. So what you want to do is you want to scale it up by a certain number. So maybe like 1.05 or something. I believe my gyro was 0.91, but like the team that I was working with a couple days ago, this is 1.03, so it could change. So I'm just going to assume it's 0.91. And before we do anything else, we're going to also put this in our Initialize file. So we're going to put this here, and we're going to delay by 2,000 milliseconds. And the reason that we're doing this is because the gyroscope needs some time to calibrate itself whenever it turns on. So by defining it here and then waiting 200 milliseconds, what you're effectively doing is giving it 2 seconds to calibrate itself. Normally it only takes like 1.5 seconds, but you want to give it a little bit extra. So with this in mind, don't start your autonomous until at least 2 seconds after you've connected to the controller. Otherwise, your gyroscope value will be corrupt and your robot will spin in circles. I'm not kidding. This has happened multiple times to me. And the one last thing you want to do is go to your globals file. And then we're going to define an extern pros ADI gyro here. And the reason you want to do this is because if you don't, then it'll think you're defining a gyro here and you're defining a gyro here, and it'll error out because it thinks you're defining two objects in the same object in two different places. But I think I explained this last time, by putting extern, it lets you define it in separate files multiple times to use as you wish. That's the simple way of putting it. Okay, so now that we have our gyro in our drive source file, you can use it in this function. So how are we going to use the gyroscope? So I'm going to put a very brief example on the screen, and it's going to show a robot in turning point driving backwards, and it's going to hit either a fence or post or both. And it's going to correct itself, so it keeps going straight, and then it's going to park. Without the gyroscope, it would not have been able to do that. So that's just an example of how useful this really is. So if you hit a pole for whatever reason in this game, you will be able to correct yourself. Might not correct yourself 100% perfectly, but it's definitely better than what would have happened otherwise. So how do you use the gyroscope in this way? So let's think about it. With the Cortex system, when your robot turns left, your gyro value goes positive, and when you turn right, your gyro value goes negative. It's like a unit circle. I don't remember if this is the same on V5. It might be the opposite way. But if it is, all you need to do is switch the wire on your gyroscope so that it's plugged in with the 3 pins the opposite way, and then all your values will be flipped, which is good. But for the purposes of this tutorial, we're going to assume that turning left is a positive value and turning right is a negative value. So if you think about it, let's say that you hit something with your left side. So now your left side has traveled less than your right side, and you've effectively turned a little bit left. That means your gyro value will be positive. And what you can do is you can add that positive value to your left side of the drive. So you can literally just say plus gyro.getValue. And then since your right side is ahead, you want to subtract it from your right side. So you want to do minus gyro.getValue. So let's run through a quick scenario. So let's say you hit something on your right side now, and now you've turned right. So your gyro value is negative. And if you think about it, your left side's traveled further, so you want to subtract something from it, and your right side has traveled less, so you want to add something to it. So remember that your gyro value is negative. So you're adding a negative number, which is indeed subtracting from your left side, and you're subtracting a negative number, which is indeed adding to your right side. So this is perfect. You may be thinking, isn't your gyro value multiplied by 10? So if you turn 10 degrees because you hit something, then your gyro is going to add like 100 to your motor value. You are absolutely correct in that this is the case. So you might be thinking, well, let's scale down this. We're gonna divide this by 2 so that it doesn't affect it as much if you hit something. But if you think about it, would your robot ever really get to that point? Let's say you're going straight and then for whatever reason, you just start very slightly veering off to the left. Your gyro angle is going to be like I don't know, 0.5 or 1 degree. So all you're really doing is, since it's multiplied by 10, you're adding 10 to this side and subtracting 10 from this side, which is all you really need to do. That's a very small addition. So yes, if you get to that 10 degree mark, it's going to be adding a huge number to this side, but you're never actually going to get to that value. So you really don't need a scale. But if you find that this is too much correction for you, you can just divide it by 2 or multiply it by 0.75 or whatever floats your boat. I just did that incorrectly. Wow. Okay. So you can just do that. And make sure to do it on both sides. The last thing you want to do is also reset your gyro. So in this little area where you reset your encoder, you do want to reset it back to 0. Because let's say it starts, you start driving and your gyro is at a value of, 100, then it will be doing what I said would be very drastic. So you do want to reset this back to 0. Okay, so this is a very basic driving forward and backward function. It does, by the way, this gyro stuff does work for when you're driving backwards with the turning. We use this almost the entire season of Turning Point, and it's worked wonderfully. Okay, so this does wrap up, this little very basic translate function. We've also defined it here. We've created our 2 helper functions. And so now this would work. And then, next we'll be covering our rotate function. So let's say we want to rotate 90 degrees at a speed of 100. Actually, more like a speed of 64 to be safe. But this is what we're going to be covering next. But yeah, so that covers just this very basic translate function. Hope to see you guys in the next one. Bye.